Dear students, in last class we have discussed the introduction of magnetostatics. In that introduction, we have discussed the one experiment, that is Oersted experiment. In that experiment, we have discussed how the magnetic field is generated, how it is a current carrying a conductor is experiences a magnetic field surrounded by it. So that is, we know that. Here we have taken one example. This is the conductor, and if I applied the potential difference here, then what will happen? The current is passing through this conductor. When it is passing through this conductor and surrounded by this conductor, the sum of the force is generated. That force is called as a magnetic force. So if you want to see the direction of the magnetic field, so here one point I have taken. For this point, if you see, then the magnetic field direction is inward to the screen. So if you see here, it is a different manner, and if you see here the direction, it is a different. If you see here, then the direction of the magnetic field is out of the page or out of the screen, and here if you see, it is a different, and every point the direction of that magnetic field is a different. And what happened here, this magnetic field is created by a circle up surrounding by the that current carrying conductor. And now here at this point we have a different magnetic field, at this point we have different magnetic field, at this point, at every point surrounded by that conductor, it is having the different magnetic field. And now here, how to get the direction of that magnetic field? He used one theory, that is right hand rule. He used one rule, that is a right hand thumb rule. It is called as a thumb rule. And if you took one conductor, and then if you place that conductor into your hand, and the forefinger is attached to that conductor, and then that forefinger is gives the direction of the current. And next what will happen here, the another four fingers are there, those fingers are tightly attached, or it is a grip, it is called as a grip, tightly grip to that conductor, and then those fingers are gives the direction, those fingers are gives the direction of the magnetic field. And here if you change the direction of the current, if you change the direction of the current, and what the direction of the magnetic field you will get. So see here, this is the first diagram. The direction of the current is in below, it means downward direction. Then the magnetic field, then the apply this theory only, which theory, thumb rule, and the magnetic field is in this direction, will get the this direction. If you change the direction of the current, then what will get, you will get in a different or in opposite direction. So this is use the direction of that magnetic field generated by the current. So now what is the use of all these things? See here, in electrostatics, how the Coulomb law is having a role to get the field, electric field. So likewise in a magnetostatics, this Biot Savarts law is having a role. It means to get a magnetic field, how much magnetic field is generated by this conductor which is carrying the current. So how it is, we will see by using that theory which is explained by the Oersted in 1820. So Biot Savarts law, how this law is there? So two scientists one of the scientists Biot and another one is Savart. So combining these two scientists' name, they put a law that is a Biot Savarts. So what it explains in physics, it is a very interesting and it is a very special electromagnetism, and the Biot-Savarts law is a equation. It describes the magnetic field generated by the constant electric field. So it explains the magnetic field which is generated by the constant electric current, and it is relates the magnetic field to the magnitude. How it is, I will show in this lecture only. The magnitude and direction, length, and electric current. So here already I have told that is how the Coulomb's law is having the role in electrostatics. Likewise, in a magnetostatics, Biot-Savarts law is also having a role that is called as a fundamental role. So these two scientists are gave this law, that is a Biot-Savarts law. So one of the name is James B. Biot and another one of the name is Felix Savart. So they derived a mathematical expression for the magnetic flux density. So at the point due to a nearby current carrying conductor in 1820, viewing the deflection of the magnetic compass needle, these two scientists are concluded that any current element projects a magnetic field into the space around it. So how the expression is derived, we'll see now. Expression of Biot-Savarts law. Here, to deriving this expression, we required a current carrying conductor. So this is the current carrying conductor I have taken. And very interesting thing is there, that is for Biot-Savarts law, for any type of the shape, for example circle, or for example a triangle, a complete loop of the square, otherwise a triangle, otherwise any shape of the wires you can use to find the magnetic field here. Now for this complete wire from this point to this point, we'll select some part from this wire. We'll select some part which is I have taken here pink color. This part, for this part, this is a infinite length of the wire. It is called as a infinite length of the wire. For this infinite length of the wire, I am going to select this much of the length of the wire. So that is dl, the length small. From this part I am going to derive the expression of Biot-Savarts law. So therefore for this expression we required where the magnetic field, from where the magnetic field you are going to find. At this point I am going to find the magnetic field which is generated by this conductor carrying a current. So now we'll give for this one, this is a P point. So therefore at P point we are going to find the magnetic field. So and then current is in this direction I. Current is moving through that wire in this direction. So therefore this magnetic field is into the phase. If you applied the right hand thumb rule, then you will come to know this is the into the phase. And now here we require another one of the information, that is the distance from the dl small element. It is called as a current element. So small element from this point to the where we are going to find the magnetic field. So at this point to this point we are going to find the magnetic field. So that is the distance between the small element to the a point of the P, that is gives a R. We have taken a distance R, and now B is a very small. So here also, why? Because here if you 1 2 3, so some parts you make and then you will get a dl. So integrated that one, then you will get the complete infinite length. So therefore what we are going to do here, we are going to find the small value of B. So therefore this is, we have taken a, instead of a B, that is dB. So therefore now current exists, it means, now current exists, it means the magnetic field is generated at this point, but I am going to find the magnetic field at this point when the current is exist into the wire. So therefore what will happen, in the conductor the current is increases, in the conductor the current is increases, then the magnetic field is also increases. It means that is gives the, in the conductor current is increases, then however the current is increased, the magnetic field is also increases. So that is the one first point. Now if I taken a current is doubled, it means if I increase the current as a double, so then what happened in the magnetic field? If you increase the current in the wire as a double, then the magnetic field is also increases as a double. It means however you are increasing the current, the flow of electrons or flow of charges, the flow of charges at this portion is increases. So how the flow of charges is increases, likewise what will happen, the in the magnetic field is also going to be increases. So therefore this current and the magnetic field, this current and the magnetic field are directly proportional. It means that first point is there, the I is directly proportional to the dB. I is directly proportional to the dB. Sorry, otherwise vice versa we can write, that is dB. We are going to find the dB now, that's why I will write dB is directly proportional to the current I. And now second part, so another one, that is in infinite length. It means from this point to this point we can divide number of the dls here. It is not definite, you can divide into a different size or a different length of the dls. It means different length of the dls, it may be 1 mm, it may be 10 raised to minus 9, it may be 10 raised to some, whatever the dls you can generate here. For each of that dl, what the flow of charges is there, it means if we increase the length or a dl, so the flow of charges is a maximum here. So that's why what will happen, however you are increasing the dl, likewise the magnetic field is also increases. So therefore we can write that point, that is dV is directly proportional to the dl. dV is directly proportional to the dl. So similarly third point, that is if we are increasing this distance r, if I am taking at this point, so if you are increasing r, then it should decrease the b. If it is increases the d r, and then the magnetic field is goes on decreases. So how much it is decreases, and then here it is also, however the inverse square law is obeys in electrostatics, likewise in the magnetostatics also the inverse square law is obeys. So therefore if you increase the 2 times of r, then in a magnetic field it is going to be decreased as a 4 times. So therefore here how it is, the B is directly proportional to the 1 by r square, it means inverse square law. So therefore here B is directly proportional to the 2r square, that distance is a double, so therefore it becomes directly proportional to the 1 by 4 r square. So the magnetic field is decreased as a 4 times, and here this we can write at a third point, dB is directly proportional to the 1 by 2 or inversely proportional to r square. Now next point here, this is the conductor and this is the dl I have taken, and this is the point which is I am going to find the magnetic field and which is at the distance r. So here with the dl which is making an angle theta at the point of p, so that is gives the, it depends on dV is directly proportional to the sine of theta. dV is directly proportional to the sine of theta. Now the expression becomes, the Biot-Savarts law, the expression becomes dB is directly proportional to the current and dl length, small element, and sine of theta divided by r square. So here we can write dV is equals to the proportional constant is mu divided by 4 phi, idl sine theta divided by r square. So this is the expression of Biot-Savarts law. This is the expression of Biot-Savarts law. So here the mu naught is equals to the value of that mu naught is 10 raised to minus 7 Tesla meter per ampere. So here mu naught divided by 4 phi. So you can write this permeability. So that is absolute permeability, it is called as a absolute permeability, 4 phi into 10 to the power of minus 7 Tesla meter per ampere. So therefore we will write here dB, the magnetic field dB is equals to the mu naught divided by 4 phi into idl sine theta divided by r square. This is the scalar form, Biot-Savarts law. So now we will write a vector form of Biot-Savarts law. So therefore this becomes mu naught divided by 4 phi I into dl cross of r divided by r cube. So this is the vector form of Biot-Savarts law. So now here, what is the direction of this magnetic field? The direction of the magnetic field at point due to this current is perpendicular to the current element. It means this is nothing but the current element. What is a current element? A current element is a small portion of conductor carrying a current. It is written as a dl. And here the direction of the magnetic field is a perpendicular to the that current element to the plane containing a current element and at a point. So therefore the dl is perpendicular to the r. we will write. So if you took a plane of the paper here and take one wire and put into the data paper, and then current is in this direction, and then what happened here, if you the direction, if you see in a direction of the data magnetic field, you will see like this on the paper. So therefore the current is in this direction and magnetic field is in this direction. Always it is a perpendicular to each other. So now I will give a homework to you all to solve, to write the answers. First question, what is the magnetostatics? So second question, what you come to know from Oersted experiment? Third question, derive the expression of Biot Savarts law.